All right, guys, this is 6.1 composite functions. So we know how to take two functions, combine them into one using addition, adding two functions, multiplying two functions, subtracting two functions, or dividing two functions. We can evaluate them when we are given an x, or even when we're given a y, we can find an x, right? And then we can create graphs of functions, we can read graphs of functions. Now, we're going to compose functions, which means creating a new function from two functions, not through addition, subtraction, multiplication, or division, but by substituting one function into the other function, okay? So if you are given two functions, f and g, the composite function denoted by f of g is found by substituting function g into function f, okay? Start with f and put g into it, okay? So let's say I had f of x is equal to 3x plus 4, right? And asked you, what is f of 2, right? Notice the wording, f of 2. That's the same phrase as f of g. How do we find f of 2? You take the 2, substitute it into f of x for the x. Yeah? So f of 2 is equal to 3 instead of x times 2 plus 4. 3 times 2 is 6. 6 plus 4 is 10. So we say f of 2 is 10 because f of x is 3x plus 4. So when I put in a 2 for that x, I get 10 as the 3 times 2 plus 4 answer. How do I find f of g? Take g and put it into f instead of the x. Okay? So suppose in example 1, suppose that f of x is equal to x squared plus 2x minus 5 and that g of x is equal to 3x plus 1. Right? Find the composition and state the domain of f of g of x. Okay? F of g of x. F of g of x is equal to, start with the function f. Everywhere that there is a variable, just like everywhere that there is an x, we substitute it in a 2. Now, start with f. F of x, they said, is x squared plus 2x minus 5. Everywhere that there is a variable, so that means here and here, everywhere that there is a variable, substitute the entire function 3x plus 1. G of x is 3x plus 1. So f of g of x is, instead of x squared, I'm going to put in, with parentheses, 3x plus 1 squared plus 2 times 3x plus 1 minus 5. Good? So I took all the variables x, and instead of putting in a number, I put in the entire g of x function. From here, it's just using your algebra skills, right? To square is to multiply something by itself, and then to distribute the 2, instead of just to x, now the 2 is being distributed to the 3x and to the 1. Good? How do I clear these parentheses? By using the distributive property, right? So this we will expand to become 3x plus 1 times 3x plus 1. It's not going to be 3x squared times, 3x squared plus 1 squared, right? Plus that 2, I can distribute it. 2 times 3x is 6x. 2 times 1 is 2. Good. Now, it wouldn't be the distributive property, it'd be more of a, it is the distributive property, but it's more of a FOIL, right? 3x times 3x, 3 times 3 is 9, x times x is x squared. So 3x times 3x is the 9x squared, 3x times 1 is 3x, 1 times 3x is 3x, and then 1 times 1 is 1. So 3x plus 1 quantity squared is 9x squared plus 6x plus 1 plus 6x, and then that 2 minus 5, you can just call it a negative 3. Good. Now we can start combining like terms. We'll just leave 9x squared. Nothing to combine. We can say 3x and 6 becomes 12x. And then that plus 1 minus 3 is a negative 2. Good. F of g of x is equal to 9x squared plus 12x minus 2. Good. We found it by substituting the g of x into the f of x. The second one asks us to find g of f of x. Oops. G of f of x is going to be g of f of x. Oops, you couldn't see that. I apologize. So now, instead of starting with f and substituting in g, we're going to start with g. (3x plus 1). And for that variable, substitute in f of x. So we're going to have 3, but now times x squared plus 2x minus 5. And we're just going to distribute the 3. 3 times x squared is 3x squared. 3 times 2 is 6x. And then 3 times a negative 5 is a negative 15. So g of f of x is equal to 3x squared plus 6x minus 15. Oh, sorry, plus 1. Good. So it's actually 3x squared plus 6x minus 14. Good. All right. And then it also said, let us not forget, it asked us to find the domain. The domain is going to be all real numbers, except we're going to exclude any value that causes us to divide by 0 or that causes us to have a negative number under the radical. Good. So if x is under a radical, under an even radical, or if x is in the bottom of a fraction, in the denominator of the fraction, we need to exclude those values from the domain that would make that into 0. So in this case, x cannot be 0, and in this case, x has to be greater than or equal to 0. For that one, and for that one, it cannot be 0, and for this one, it has to be greater than or equal to 0. Neither of these. This is just a regular trinomial. There are no fractions, there are no radicals, so we're just going to say the domain is from negative infinity to infinity, or all real numbers. Same here. It's just a trinomial, no fractions, no radicals. So we're going to say the domain is all real numbers. Example 2 again asks us to find f of g of, instead of just x, they give us a number. Okay, so you can complete the steps with your practice and then substitute in that number to the final function, or you can work backwards. Okay, so for all of these, a, b, c, and d, f of x is equal to 5x minus 1 and g of x is equal to 3x squared. Okay, so if I was to do f of g of 1, f of g of x is going to be that f of x, 5x minus 1, but instead of x, right? I'm substituting in g of x. 3x squared minus 1. Good? Distribute that 5. 5 times 3 is a 15. X squared minus 1. Now, take that 15x squared minus 1 and substitute in the 1. So f of g of 1 is 15 times 1 squared minus 1. Oh, sorry, you couldn't see that. 1 squared is just 1, so that's 15 times 1 minus 1. 15 times 1 is 15, minus 1 is 14. So this is 14. Good? And then I said, or you can work backwards. Substitute 1 into g of x. Okay? So take that 1 and say 3 times 1 squared is 3. So when x is 1, g of 1 is the number 3. Take that number 3 and substitute that into f of x. Okay? F of x is 5 times x minus 1, so that's 5 times 3 minus 1 is 14. Either way, you get the same answer. Okay, so you can either find f of g of x and then substitute in the 1, or you can say what is g of 1, and then the answer to g of 1 substitute into f of x. B asks us g of f of 1, but I'm going to do this way first. G of f of x is, start with g, 3, but where x is, substitute in f of x. So 3 times 5x minus 1 squared. Good? 3x squared becomes 3 times 5 minus 1 squared. 5 minus 1 is 5x minus 1 times 5x minus 1. Still times 3. Okay, I'm going to do the FOIL first. So that's going to become 5x times 5x is 25x squared. 5x times a negative 1 is a negative 5x. Negative 1 times 5x is a negative 5x. And then negative 1 times negative 1 is a positive 1. Still need to multiply that by 3. So that's 3 times 25x squared. That's going to be minus 10x plus 1. 3 times 25 is 75x squared. 3 times negative 10 is a negative 30x. And then 3 times a positive 1 is plus 3. That's g of f of x. So g of f of 1 is 75 times 1 squared minus 30 times 1 plus 3. 75 minus 30 plus 3. 48. Good? All right, if we were to work backwards using the work backwards method, you put in a 1 to f. 5 times 1 minus 1 is 4, right? 5 times 1 minus 1 is 4. 5 times 1 is 5. 5 minus 1 is 4. Good? Now, take that 4 and put it into 3x squared. 3 times 4 squared is 48. Same answer. Good? Okay, C asks f of negative 2. We can do it. F of negative 2. F of negative 2. So we'll start with f of x. take f of x, which is 5x minus 1, instead of saying 5x, we're going to use 5x minus 1 as my x minus 1. So I took f of x and put it inside f of x. Now I'm going to distribute that 5. 5 times 5 is 25. X, 5 times negative 1 is a negative 5 minus 1. So that's 25x minus 6. So f of negative 2 now is 25 times negative 2 minus 6. Good? 25 times negative 2 is negative 50 minus 6, negative 56. Good? All right, take negative 2 and put it in for f of x. 5 times negative 2 minus 1, it's negative 11. Take that negative 11, put it into f. So now it's 5 times negative 11 minus 1, negative 56. g of x or g of negative 2, sorry. So we're going to take g of x and put g of x inside of it. So that becomes 3 times x squared, but x squared is now 3x squared squared, right? Okay, what does this mean? The 3x squared squared, 3, now I'm just going to distribute the 2 because it's one term. So 3 squared is 9, x squared squared, we have to multiply the 2 times the 2 and we get 4. So that's now 3 times 9x to the 4th. Good? 3 times 9 is 27, x to the 4th. Good? And then g of negative 2 becomes 27 times negative 2 to the 4th. Remember your parentheses, 432. Or negative 2 to the 4th. Negative 2 to the 4th is 16. 27 times 16 is 432, just in case you were wondering. All right. Equals 432. All right, let's take negative 2 and put it into g. G is 3x squared, so 3 times negative 2 squared is 12. Now we're going to take that 12 and put it into g again. So instead of 3 times negative 2 squared, it's going to be 3 times 12 squared, which is 432. Okay. Example 3 asks us to find the domain of f of g if f of x is equal to 1 over 1 plus 4 and g of x is equal to 4 over x minus 3. So this is going to become a compound fraction, which means a fraction within a fraction. Everywhere that there is a variable, well, let's look at it. F of g of x. So we're going to take f of x, but anywhere that there is a variable, we're going to take that and substitute it with all of g. So instead of f of x is equal to 1 over x plus 4, we're going to have f of g of x, which is 1 over 4 over x minus 3 plus 4. Instead of that x, we have 4 divided by x minus 3. Good? Now what do? We want to simplify this. All we need to do is simplify it. They didn't give us a number to substitute in for x. They just asked us to find the domain of it. In order to find the domain, we just want to simplify it so that we can ensure that if there is a remaining fraction, that we do not have an x value that gives us a 0 in the denominator of the fraction. Okay? So, what do? In a compound fraction, a fraction within a fraction, we can get rid of the inner fraction, like the inner parentheses. This is the inner fraction by multiplying the numerator and the denominator of the bigger fraction by the denominator of the inner fraction. So in this case, the inner fraction is 4 over x minus 3. So we're going to take the denominator of the inner fraction and multiply the numerator and the denominator of this fraction by the inner fraction. So I'm going to write it again. 1 over 4 divided by x minus 3 plus 4, and we are going to multiply that by x minus 3 1 times x minus 3, and on the bottom 4 divided by x minus 3 plus 4, all times x minus 3. Okay, let's distribute that. 1 times x minus 3 is just 1 times x minus 3, or you can just call it x minus 3 on the top. Here, you need to take that x minus 3 and multiply it by each term in this binomial. So that's going to be the original 4 divided by x minus 3 times x minus 3, which is handy, right? Because then those cancel each other out, plus 4 times x minus 3. Good. This could also be seen as, in fraction form, x minus 3 over 1, if that's easier. So we took that x minus 3, we multiplied it by this term. We took that x minus 3, we multiplied it by this term, and we multiplied it by this term. So that now we have x minus 3 on the top. Here, these are going to cancel. 4 times x minus 3 divided by x minus 3 times 1 is just going to give us 4 over 1, or 4. And then 4 times x minus 3 we're going to distribute. Plus 4 times x is 4x, and then 4 times a negative 3 is a negative 12. Good. So now we have x plus 3 divided by 4 plus 4x minus 12. You can simplify that further. Four minus 12 is going to be a negative 8 and a 4x in front of it. X minus 3 divided by 4x minus 8 is as simple as we can make f of g of x, but it asks us to find the domain. So what value can be multiplied by 4 and then have 8 subtracted from it and equal 0? What value can equal 0 if I multiply it by 4 and subtract 8 from it, right? So take your denominator and set it equal to 0. And solve for x. Sorry, I just started doing it. X is equal to 2, and that is what you must eliminate from your domain. So your domain is all real numbers except that x cannot equal 2. Or the domain is from negative infinity to 2, and then 2 to positive infinity. Good? If f of x is 1 divided by x plus 3, and g of x is equal to 3 divided by x minus 2, what is f of g? And what is the domain? And what is f of f? And what is the domain? Just for fun, yeah? So let's find f of g. F of g, 1 over x plus 3, but I'm going to put the g in for that x. 1 over 3 divided by x minus 2 plus 3, because this was my g. And I substituted it in for that x. Good? Take the denominator of your inner fraction and multiply both the top and the bottom of your fraction by that. So 1 is going to be multiplied by x minus 2, and then 3 divided by x minus 2 plus 3 is going to be multiplied by x minus 2. So that's going to give us simple x minus 2 on the top. Down here, it's going to give us 3 over x minus 2 times x minus 2 plus 3 times x minus 2. So that's going to cancel. We'll have x minus 2 on the top, and on the bottom we'll have 3 plus 3 times x is 3x minus 6. So that'll be x minus 2 over negative 3 plus 3x for f of g. F of g of x is x minus 2 divided by negative 3 plus 3x. What do we have to eliminate from our domain? Take your denominator, negative 3 plus 3x, set it equal to 0, and then solve for x. So, I don't know why I wrote it like that. It should be 3x minus 3. Anyway, solve for x. So add 3, it'll be 3x equals 3, divide by 3, and we'll get x is 1. So x cannot be 1. Good. And then f of x, we're going to take just f of x, 1 divided by x plus 3. And instead of x, we're going to put the whole 1 divided by x plus 3 in for x. Obviously, we need to multiply both the top and the bottom by x plus 3. So you get x plus 3 on the top. On the bottom, 1 over x plus 3 times x plus 3 plus 3 times x plus 3. X plus 3 divided by 1 plus 3x plus 9 is x plus 3 over 3x plus 10. Good. The domain, we cannot have 3x plus 10 equals 0, so I'm going to set it equal to 0. X cannot be negative 10 thirds. Good. All right, and then find what f, up here, find what f and g are so that f of g is equal to h, and h is the absolute value of 3x plus 2. What is f and what is g? So remember, f of g is equal to h, and h is the absolute value of 3x plus 2. Means that if I put g inside of f, I get that. If I replace every x in f with g, I get the absolute value of 3x plus 2. So that means f was the absolute value of x, and g was the 3x plus 2. G of x fit inside f of x instead as a replacement for the x. Okay? Example 5 then asks us, if f of x is equal to 2x minus 5 and g of x is equal to x plus 5 divided by 2, show that f of g of x is equal to g of f of x, and they are both equal to x. Okay? So, if you are looking at a function and you describe x is being multiplied by 2, and then we subtract 5 from it. Here, x is being added to 5, and then we're dividing it by 2. So you can see that it's being multiplied by 2 here, it's being divided by 2 here, it's being subtracted, 5 is being subtracted from it here, 5 is being added to it here. So you can see that some of the operations are the inverse. The operations of f of x are the inverse of the operations of g of x. And when you combine them via substitution, they undo each other. Okay? So, f of x is equal to 2x minus 5, and g of x is equal to x plus 5 over 2. Let's find f of g of x. F of g of x is 2x minus 5, but instead of x, I'm going to put in x plus 5 over 2 minus 5. So I took f, 2x minus 5, and I substituted in x plus 5 over 2 for the x. That went there, right? Now let's simplify it. Here, x plus 5 is being divided by 2 and then multiplied by 2, so those cancel. X plus 5 minus 5, the adding 5 and subtracting 5 cancel, and we just get x. G of f of x means we start with g, x plus 5 over 2. But instead of x, I'm going to put in 2x minus 5. Good? So now it's 2x minus 5 plus 5 divided by 2. Minus 5 plus 5 cancel each other out, and we just have 2x over 2. 2 divided by 2 is 1, so we just have x. Good? So when two functions, regardless of which direction we compose them, When they are composed, leave you with an x, the functions are called inverse functions. To invert is to undo something. So division here undoes the multiplication here, addition here undoes the subtraction. F undoes a g and g undoes x. So these are called inverse functions. They undo each other. And that is the end of 6.1. Thank you guys so much.